Hello students. In the last lecture we have discussed regarding the cyclic structure of glucose, and in the today's lecture we are going to discuss the structure of a fructose. So what is the main difference between glucose and fructose? Okay, so in the glucose what we have seen that there is a CHO group at carbon number 1, that is aldehyde, but in case of fructose it is a what it is hexoketose. What it is? Hexoketose or ketohexose. What we call it as hexoketose or ketohexose. Okay, so it means that it has a functional group of the ketone. It is just a carbonyl group. It is not a CHO. It is a C double bond O, and at both sides there are carbon atom. Now, if we write a Fisher open chain structure for fructose, what it is, this is carbon number 1, and this one is second, third, 4, 5, and the 6. Correct. Now while forming the cyclic structure, the OH of carbon 6th carbon atom, this attacks on the carbonyl carbon atom. And what happened? This carbonyl carbon, which is sp2 hybrid, it becomes a sp3 hybrid. Okay, and this will become a chiral carbon atom. And now if this carbonyl is converted into chiral carbon atom, there are two possibilities. Why? Because as we have discussed, the carbonyl structure is planar structure. And when we are discussing the glucose, we have discussed that this is a planar structure. So the OH may attack from this side or from this side, back side or front side. So due to attack of this OH from carbon number 6, what we are getting? We are getting a structure. Now how many members are present in the ring? 1, 2, 3, 4, 5. This one is sixth one. Okay, sixth one. Oxygen is sixth. Okay. So this OH from the sixth carbon atom attacks on the carbonyl carbon, and it becomes a chiral. And what we will get it as a, we can write a structure over here like this. This is carbon number 2. Okay. Then OH over here. Then C3, C4, C5, and C6. This is what? CH2. Okay, and this is the third carbon atom, which has OH on left hand side. This is fourth one, OH on right side, fourth and fifth. Similar like this. Okay, hydrogen here. Here is also hydrogen. And now at this second carbon atom there is a CH2OH, so we can write over here CH2OH. Clear? And this will form a bond with, which one it is? OH of sixth carbon atom. Okay, so this is 1, 2, 3, 4, 5, 6 membered ring. Okay, so another possibility is that now here what we have written OH on right hand side. Now this is become chiral, so another possibility is there. This is your C2, 3, 4, 5, and sixth one is CH2. Okay, here it is CH2OH. go to this side, this is OH, this one is third, so H, OH, and this is H, OH, H, OH. Okay, and this, now this carbon number 2 is joined with oxygen atom to form a cyclic structure. Now this is regarding the D fructose. Okay, alpha D fructose. Okay, or we can say, sorry, this is D minus fructose. Okay, now we will draw the Hayward's formula for this. Okay, and keep in mind that we have to draw an oxygen atom at the right hand side top corner, and remaining all are carbon atoms. Okay, so this one is our C2, C3, C4, C5 and C6. Correct. Now at this C2 position, okay, the groups which are present on the right hand side, what we have to write, the groups which are present on right hand side, what it is, right hand side below and left above. Correct. So we will write over here OH, H, OH, OH. So here OH, EH, then OH, then here also OH, and in the case of this CH2, what do you want? Okay, both are H. So this is the case. Now the groups which are on left hand side, they are above. CH2OH. Okay, then here it is OH, here H, H, this one is also H. What is this? This is the alpha D minus fructose. Alpha D minus fructose, or what we can say that alpha D minus fructopyranones. Because it is forming a 6-member ring. Okay, likewise for this structure we can draw a Hayward formula. So always keep in mind oxygen on the right top. Okay, then this one is second, third, fourth, fifth and sixth. At 6 there are hydrogen atom, you can write directly. Okay, whatever is on the right hand side, it is down. CH2H below, H, OH, OH, likewise here H, and OH, OH. Clear? So this is what this is. This is our beta D minus fructose, or what we can say that beta D minus fructopyranones. Clear? So this is what? This is the cyclic structure. Okay, a pyranose structure. Now So fructose in free state, whatever it is, sorry, free state pyranose, 6-membered ring. In the free state, it has a cyclic structure of pyran, or it is called as fructopyranose. But in combined state, that is in disaccharides or in polysaccharides, it has a structure of furanones. So furanones form. So what it is? 5-membered ring which contains oxygen. So what we have discussed in the first lecture, one is pyranose and another one is furanose. So this is furanose, like this. This is what your furan. Okay, so the structure resembles to this, and that's why it is called as a furanose. So while writing the furanose, okay, what we have to write now, whenever we want a 5-membered ring, it means that the carbonyl carbon, so here at the center I will write first CH2OH, this is C double bond O, this is third carbon atom, so it has a hydrogen over here, OH on the left hand side, fourth OH, H, fifth OH, H, and sixth is CH2OH. Now what we are going to discuss, that is 5-membered ring structure, furanose. So in case of this 5-membered ring, the hydroxy group of 5th carbon atom, this attacks on carbonyl carbon atom. Okay, and what will happen? This carbonyl carbon is going to convert into the sp3 hybrid. Okay, so there are once again two possibilities: backside attack or front side attack. We can write over here OH, then CH2OH, okay, then H, OH, OH, then H, this is H, this is our CH2OH, and the carbon get connected with oxygen from carbon number 5. So there is a linkage between intramolecular hemi-ketal at C2 and C5 due to attack of C5OH or C2 carbon atom. Okay, so this is one, and this is what we can say it as alpha D minus fructose. Okay, or you can say it as alpha D minus fructofuranose. Okay, likewise we can write a structure for this also. Here CH2OH to this side, OH on the left, and here H, OH, OH, H, fifth carbon atom H, CH2OH. This forms a bond with this carbon atom. And what is this? This is our beta D minus fructose, or what we can say that beta D minus fructofuranones. Okay, so we will go for the fructofuranones. We will go for the Haworth's formula for this. So Haworth formula. Now we are drawing a 5-member ring. So oxygen is at exact top position. Draw first a 5-member ring. Then this is our C2, C3, C4, C5. Okay, and always remember that the CH2OH at C5, this is at the top position, hydrogen is at down. Correct. Now at C2, whatever is right is below. Whatever is right, that is below. Then H, OH. Clear? And whatever it is at left hand side, that is at top. CH2OH, here OH, here H. This is our alpha D minus fructose, Haworth's formula, or alpha D minus fructofuranones. Likewise, here we can draw for this beta form. This again a 5-member ring, oxygen at the top. This is C2, C4, C2, C3, C4, C5. Okay, at C5, CH2OH, H. Now, whatever on right, that is below, that is CH2OH, here H and OH. Okay, and whatever is on left hand side, that is on top. So OH, OH and H. So this is what beta D fructose, beta D minus fructose, or beta D minus fructofuranones. Is it clear now? So what? Once again, we will start from the in the free state. Fructose is present as a pyranose, what we have discussed before. Here, this is the pyranose. Okay, so alpha D fructose, beta D minus fructose, but in the pyran 6-member ring, which consists oxygen in the free state. But in the combined state, it presents as a furanose and furanose. Okay, so it is a 5-member ring which consists of one oxygen. So the 5th carbon atom attacks on carbonyl to form an intermolecular hemiacetal, which gives us a 5-membered ring. Okay, and depending upon the position of OH, this one, here OH is down, so this is alpha. Here OH is up, and that's why beta. Clear? So this is regarding the structure of fructose. Okay, so in the textbook we have disaccharides also. We have structure of sucrose, then maltose, lactose. Okay, so we have to study the disaccharides, okay, for GE NEET purpose, but for the board purpose, the part of disaccharide is removed. Okay, so we are not going to deal with the structure of disaccharides. Okay, and what is glycosidic linkage, how it is linked, alpha beta form, alpha form. Okay, so that we are not going to deal with in this particular this year, but you have to study for that NEET and JEE. Okay, so this is regarding the carbohydrates. Protein we will discuss in the next lecture. Thank you.